Okay, so the general exponential function is of the form y equals b to the x, where b is bigger than 0 and not equal to 1. So in other words, if it was like y equals 1 to the x, well, think about it. Y equals 1 to the x, no matter what x is, 1 to any power is just 1. And that would be just a straight line going like this. So in this case, b can't be 1, it has to be bigger than 1, or it can actually be less than 1 and bigger than 0. But if it was 2 to the x, then it would have this shape here. And then 10 to the x and so forth. So like the bigger the number under the x, the question is what happens to the graph. So for the general exponential function, y equals a times b to the x minus c plus d, the larger b is the number to the base and to the power of x, the steeper the graph is. For instance, 10 to the x will be steeper than 2 to the x, which will be wider. Positive values of c move the graph c units to the right. Negative values move c units to the left. So for instance, if the power is x minus 2, it's like c is 2 or positive. Therefore, it moves it to the right. But 2 to the x plus, let's say 3, the 3 is, c is actually negative 3, because negative 3 is plus 3. So we move to the left. Positive d shifts the graph up, negative d shifts the graph down. So if it's like y equals 2 to the x plus 5, then we're actually shifting the graph of y equals 2 to the x up 5 units. Now, if a and b are bigger than 0, the curve will be increasing, so in this direction. If a is bigger than 0, but b is between 0 and 1, the curve is decreasing. The reason for that is because if, say, b is a half, so it's a half to the x, the bigger x gets, the smaller that fraction gets. So we're actually decreasing in values. For instance, like a half to the 1 equals a half. But a half cubed equals 1 over 8. And that's smaller. So the bigger x gets, the smaller b to the x gets. Now, if a is negative, the front number is negative, and b is bigger than 1, the curve is decreasing again. But if a is negative and b is in between 0 and 1, like a half, they cancel each other out and it becomes increasing again. We sketch graphs of exponential functions using the horizontal asymptote y equals d, the y-intercept, and 2 other points. Now, girls, if you forget all that we've discussed so far about when it's increasing and decreasing, don't worry. You'll just be able to plot points and figure it out. So let's do one simple example. So we've got sketch the graph of y equals 3 to the negative x plus 1. First of all, I notice the plus 1. That tells me I'm shifting up 1, or in other words, the asymptote. There is an asymptote at y equals 1, or y equals d. So d is 1 in this case. So there's an asymptote here. The question is our exponential function going to go this way or this way? That's the question. We can work that out by just plotting some points. So if I put, for instance, 1 in there, so I get y, when x is 1, I get y equals 3 to the negative 1 plus 1. So I'll get 1 on 3 plus 1, or 1 and a third. 1 and a third. So that's just a little bit over the asymptote. However, if I put negative 1 in there, so here x is negative 1, I get y equals 3 to the negative 1 plus 1, which becomes 3 to the positive 1 plus 1, which is just 4. So in this case, I'm up here. So now I can see the shape of the exponential. I know it's going to be like this and go downwards. Now the question is, though, what is the y-intercept? The y-intercept is when x is 0. So when x equals 0, y equals 3 to the 0 plus 1. What's 3 to the 0? 1. Plus 1 is 2. So the y-intercept is 2. So I have 3 points. I know the rough shape of an exponential, so I know that it looks like this and approaches our asymptote. So that there is y equals 3 to the negative x plus 1. So yeah, so hopefully you've done the investigation, you understand how I got that. So basically, when you need to graph an exponential, you can work out where the asymptote is using this value here. You can sub in a couple of x values, and also you can find the y-intercept by subbing in x equals 0, and there you have it. And you can also check your exponential functions on your graphics calculator, but don't always use your graphics calculator to work it out because you may not have it like in a paper 1.